Welcome back to our lecture. Let's spend a little bit of time getting to know the RDS service in this hands-on segment. I've already logged into the AWS Management Console, and I will go to the RDS dashboard. The RDS dashboard is where I can provision and manage all of the relational databases that are created by AWS. I'm going to begin by launching a new RDS database. I'll go ahead and click on the Databases menu option and click on the Create Database button. When I do that, I'm presented with a page where I can create a new database. And there are sort of like two different creation methods that are available. One is the standard creation method where you have the ability to choose all of the options for the database service configuration. The second method is the easy create method. And that's if you want to just like quickly get it up and running with a database and you want to choose sort of like a templatized configuration, that's another way to create the database. We're going to just use the standard create method because I want you to see all of the different options which are available to you when launching a new database. Now, when creating a database, probably the most important option that you need to select at first is the engine type. And there are 6 different engines available, 6 different database application servers that you can run in the RDS service. And you might be asking yourself, well, which one should I choose? Well, this is going to be completely dependent on your application. Every application is designed to work with a particular database. And what you would find is that depending on the database type you choose, the subsequent options might change as well. We're going to use the MySQL database type in this hands-on segment. And when I choose that type, you can see that I can select the version, the exact version of MySQL. Now, you know, there are tons of different MySQL releases that are available, and the release or the version of MySQL that you choose will generally align with your application requirements. Oftentimes our applications are tightly coupled to a particular database version, and if we were to choose a different database version, we might introduce some unexpected behavior. So we have the ability to specify the exact version of the database that we want to use. We can choose a template, a configuration template. Now, what these templates essentially do is they sort of they can sort of disable some of the options, the configuration options, based upon our particular needs. So the production template is currently selected, which gives you access to all of the different configuration options. If we were to select dev test, which is what I want to use in this hands-on segment, then what you would find is that some of the configuration options are now sort of hidden or disabled. And that's just to make the process a little bit easier as you're going through. If you are creating a production server, then there are certain types of instances and certain configuration values that you might want to tune. But if you're creating a dev test or a free tier instance, then you can safely ignore some of those configuration options. Under settings, we begin by specifying the database instance identifier, which is essentially the name of the database server. Just like we can name our EC2 instances, we can name our database instances. And we'll just call this, I'll call it my database server. we need to set up some credentials to access the database server. The credentials are basically like the admin account for our database server. We can use this account to create databases on our database server and to do different database administration tasks. For the master username, I'll call it dbadmin, and I'll create a password. And of course, when you're creating a password, it should be significantly, have complexity, of course. We select the database instance size, and this is similar to creating an EC2 instance in that we specify an EC2 instance size, and there are different types of EC2 instances which are available. We can select from a couple different types of database instances, like the M-class instances, which are sort of general purpose, R-class instances, which are designed for databases and are especially memory optimized databases. And then our burstable classes. These are the free tier class. So I'm going to choose the burstable class, and I'm going to just use the DB T2 micro class, which is a small instance size. Now, if this was a production environment, of course, I would want to use something beefier, something with more CPU and more memory. But for this example, the T2 micro size is just fine. The storage type is general purpose SSD and 20 gigs of storage, which is acceptable. If I were running in a production environment, I might choose provision IOPS storage, because remember, databases are very IO intensive. Your application is making a request to the database is retrieving data that's stored on disk, scanning that data and providing a result set back. And so databases are very, very IO intensive. And in a production environment, you might need provision IOPS in order to support heavy database demand. Storage auto-scaling is enabled by default. And this is a really interesting feature, which was, at least at the time of this video was created, this is a more recent feature. And it solves a big problem. If I were to create a database with 20 gigabytes of storage, it's possible that over time I could use up all of that storage space that's available. And when the database server runs out of storage space, then bad things generally happen. It causes really unexpected and unwelcome behavior in your application. It can leave your database in an inconsistent state. It's just a really bad scenario. So in order to mitigate that, you can enable storage auto-scaling, and what AWS will do is it will automatically add storage to your database instance if you begin to exceed the current specified amount of storage. Now, that could also have undesirable, sort of an undesirable impact in the sense that, like, you could have a system it's under heavy demand and storing all this data, and it just keeps gobbling up more and more space, and you're going to pay money for that storage. And so you can define a maximum storage threshold, and let's set that maybe to like 100 gigs. And that's sort of like the max limit to which AWS will auto-scale the storage to. I talked about how these RDS databases, you can deploy them across multiple availability zones for greater resiliency. That's certainly something you would want to do in a production environment. But for this, sort of just testing purposes, we're playing around with our first database instance. We're not going to create a standby instance. Obviously, when you create a standby instance, you're going to pay for that. That's not something we would do in this sort of, when we're just sort of playing around and testing this service. We can configure the sort of connectivity of the database instances. The database This database service runs on database instances, and it's located in the same environment, what we call the VPC, the Virtual Private Cloud, as your EC2 instances. And we'll talk about VPCs in great detail in an upcoming lecture. But the important thing to understand is that you can actually kind of control how these database instances are deployed from a networking perspective. If I click on the additional connectivity configuration drop-down, then I can define a number of different configuration settings related to the database networking. I can define what's called a subnet group, and that specifies which network subnets the database instances can be launched into. I'm just going to leave that at default for now. The next setting is really important to understand, whether or not the database instance is publicly accessible. And in general, I'd say like 99% of the time, you would want this answer to be no. You would not want your database to be publicly accessible. You wouldn't want the database instance to have a public IP address. You wouldn't want people to be able to connect to the database across the internet. It's generally not what you want to do from a security standpoint. You'd only want the database to be accessible internally, and you'd want to access the database via other EC2 instances. We can define a security group for our database instance, and this is just like the security group that we would associate with our EC2 instances. Currently, it's just using a default security group, which is perfectly fine for this hands-on segment. And we can define things like the database port. This is the TCP/IP port that our client applications will use to connect to the database. And this port value is going to be different generally for every database type. We're using MySQL, and 3306 is the standard port for MySQL databases. If I click on the additional configuration link, then I can see some other options I can add. Now, when I launch my database instance, it launches the database server, but the database server really doesn't have a database configured on it yet for my application. I could bootstrap the database server by adding an initial database on it, and we'll just call this like MyDB. This isn't required, by the way. You can launch the database server and then use the admin credentials to go in and start creating databases on the database server. But if you want to launch the database server and have it set up a database, an initial database for you, you can do that here. And we can, backups are automatically enabled for our databases. That's the scheduled backup, which is performed. We can specify a backup retention period. By default, it's just 7 days. We can back up to, I believe, 35 days. Yeah, 35 days. We'll just leave it at 7. We can specify the backup window, and this could be important. I'll say select window. We might have a specific period of time, a window of time during the day during which we want AWS to initiate backups. And when the database is being backed up, the performance of the database server will decrease slightly. So you might want the database server to be backed up during an off-peak hour of the day. I'm just going to leave it no preference for now. We can set some monitoring information. We can export some log files. This is generally a really good thing to do, like export the error log or general log from the database server. We can specify the maintenance window as well. So the RDS is a managed service. AWS is spinning up the database instance for us, and it's it's deploying the database software on the instance, and it's managing that software for us. It's managing the service for us. But from time to time, AWS will need to update the database software, and that's to pull in things like security fixes and potentially minor upgrade patches. And so we can tell AWS how it should go about maintaining the database service for us. For example, by default, we can enable auto minor version upgrades, which means that when a new minor database version comes out, AWS will automatically update our server with that minor version update. And this may or may not be a desirable thing. You could potentially, from the benefit is that you are automatically getting like the new software updates, the new database updates. But if you haven't tested that new version in your software delivery pipeline, then you could potentially introduce a failure mode where your software application worked fine in a tested environment, but that was running a different version of the database software than production. You go to deploy your software in production, and it fails because of that version mismatch. So that's something to be careful with. We'll leave it enabled here in this hands-on segment. We can also specify the maintenance window. Now, in the case where we have a single database instance, when AWS needs to perform maintenance, that is going to generate some downtime. It's going to be short, but it will occur. And so we might want to have a maintenance window during off-peak hours so that our customers are not negatively impacted. If we are running in a multi-AZ mode, then what AWS will do is it will update each database instance one at a time so that customers don't experience any sort of downtime. And the last configuration setting here on this page gives you the option to enable deletion protection. And this is just like our EC2 instances. If we want to prevent a database instance from being deleted inadvertently, we can enable that deletion protection. And that's something that I actually would almost always do. Now, I won't do it in this hands-on segment because I'm going to immediately discard this database when I'm done using it. But for sure, in any sort of production environment, I would absolutely want to enable that deletion protection just to prevent somebody from inadvertently picking the wrong database and deleting it. Because deleting databases can cause significant harm to your application platform and cause you to potentially lose some data as well. Okay, let's go ahead and create the database. We'll click on the Create Database button. And when we do that, then AWS will begin to launch our database. There we go. Now, launching a database instance takes a lot longer than launching an EC2 instance because behind the scenes, there are a couple things that need to happen. AWS needs to launch an EC2 instance. It needs to configure and deploy the database software on that instance. And when it initially creates a new database instance, one of the first things it does is it actually performs a backup of the database instance, which might seem a little strange at first, but essentially it's performing that first backup, and then subsequent backups will be incremental backups, which represent the delta of changes from that first backup. So launching a new database can take 5 to 10 minutes. Now you see the database is launching. If I select that instance, then if I expand this, let's see. I select my database instance, and it's still in launch mode, so it's not going to show me too much information yet. Like, for example, it doesn't have the endpoint or port, and it's got some networking settings. We're going to let this launch, and I'll pause the video and return once the database instance is healthy. Database is done launching, and it's now available to us. Probably the most important thing to understand from a configuration standpoint is the database endpoint, which is this endpoint address down here. This is the actual endpoint address for the database. This is what you would use in your application configuration, where you're specifying the location of the database. And so that's something you would always want to be aware of. There's a lot of configuration information related to our database instance. If we click on the monitoring tab, we can see some metrics. Now, of course, we really haven't done much with this database at all. You see there's some increased CPU utilization here. Initially, when the database is being launched, that's likely due to the database backup. If I look at logs and events, I can see that the database instance was created, and then there was a backup performed of the database instance, and that's something that happens right away. We can look at things like the maintenance that's configured, any sort of pending maintenance that might be upcoming. We can look at the backup settings, and we can see the snapshots that have been created for our database. And here's the initial snapshot that was created. If we want to create a new snapshot, we can just go into the Actions menu and say, take a snapshot. We would name our snapshot. We'll just call it My Database Snapshot 1. And we say, take a snapshot. And that does a quick snapshot of that database, and you can see that it's already completed. It happened really, really quickly because there's like literally no data stored in that database server yet. Now, if we want to delete our database, then we can select the database, actions, and we can delete it here. And that's what you want to do when you're done working with the database. You can reboot the database instance if you need to. Why would you want to reboot the database instance? Well, maybe the database instance is exhibiting some sort of problem, and rebooting the instance might allow it to recover. You could also stop an instance, just like you can stop an EC2 instance. If you're not going to use the database server for a period of time, you can stop it to save on some costs. If you want to create a read replica, then you can select the read replica action, and you can add up to 5 read replicas of your database. And of course, if you want to change some of the database settings, you can modify the settings. And it's in most, so like if you wanted to increase the instance type or something, you can do that. Now, some of those settings might cause some downtime, so that's something to be aware of. Well, I hope you learned a lot about database instances in this segment, and we will continue to use the RDS service and its databases in other lessons in this course.